Dear students, welcome to today's class. Today also I am going to explain a very few problems which are very important and which are conceptual questions. Okay, how to solve the problems within short time. So if you have the fundamental grip over the concept, the solution of the problems is very easy. Okay, so without wasting our valuable time, let us start our class. So I am here, I am going to explain one concept. Limit extends to a f of x by g of x, that is f of x upon g of x exist. It is exist. We are getting a finite value. Okay, it is exist. And if as x tends to a, g of x tends to 0. Try to understand this concept. As x value approaches to a, if g of x value approaches to 0, denominator, then as x tends to a, the numerator f of x is also approaches to 0. The numerator f of x is also tends to 0. Try to understand this. First of all, this limit is exist. Some 5, 10, 11 like that. In that, if denominator x tends to a, g of x, it tends to 0. If that means if x tends to a, if g of x should be tends to 0, then as x tends to a, f of x is also tends to 0. That is the concept. Now try to understand. So one problem is given in one of the examinations. Limit x tends to minus 2, 3x square plus ax plus a plus 3 upon x square plus x minus 2 exist finitely. That means its limits is exist. You will get the answer. Somewhat answer you will get exist finitely. Then is asked to find out a value. Then how to approach this problem? See, as x tends to minus 2, the denominator, observe the denominator value approaches to which value? Let us see that. As x approaches to minus 2, see the denominator x square plus x minus 2, that is minus 2 square minus 2 that is equal to 0. That is denominator approaches to 0. As x value approaches to minus 2, the denominator approaches to 0. Then already we told, if denominator approaches to 0, then f of x is also approaches to 0. That means 3 into minus 2 whole square, a into minus 2 plus a plus 3 value is also approaches to 0. See the answer, minus 2 whole square is 4, 4 3s are 12, 12 plus 3, 15, minus 2a plus a, that is equal to a is equal to 15 is your answer. Very nice problem, very nice concept this is. So limit extends to a, f of x, g of x exists. The value should be exist finitely. And if as the denominator approaches to 0, the denominator approaches to 0, then numerator is also approaches to 0. Okay, now, so you should not take it as a 0 by 0 indeterminate form. No. After that cancellation only, we will get that answer. Understand that? So I hope that you understand this concept. So based on this, one more formula, one more very easy problem is there. Let us see that problem also. Okay, now. Limit extends to 1, x square minus ax plus b by x minus 1 is equal to 5. Then the value of a plus b is. How to do this problem? Right. What is the procedure? So as I already told you one concept, first as x tends to 1, observe the denominator. As x tends to 1, x minus 1 approaches to 0. Right or wrong? 1 minus 1, 0. X minus 1 is equal to 0. And one more thing is, this limit exists finitely. The limit exists finitely. The limit is existing. So as x tends to 1, denominator tends to 0, therefore the numerator value is also 0. That means minus 1 square minus a into 1 plus b is equal to 0. Understand this? So this is equal to minus a plus b. 1 minus a plus b is equal to 0. This is the equation number 1. This is equation number 1. Now let us solve this problem by L hospital rule. Limit extends to 1. By L hospital rule, let us solve this problem treating that it is a 0 by 0 form. Let us solve this using L hospital rule. So x square derivative is 2x minus ax derivative is a, b derivative is 0. X minus 1 is equal to 1. It is equal to 5, it is given. As x tends to 1, substitute here. 2 minus a is equal to 5. Therefore, a is equal to minus 3. A value is minus 3. Substitute a value minus 3 here. 1 minus of minus 3, 4. So, therefore, b is equal to minus 4. So, a value I substituted minus 3, minus of minus 3 plus 3, 1 plus 3, 4, b value is minus 4. Therefore, a value is minus 3, b value minus 4. Therefore, total your answer is minus 7. Understand? So, here the concept I used is, once again I am revising, as x tends to 1, the denominator approaches to 0, therefore, the numerator value is also should be equal to 0. As x tends to 1, the numerator is also approaches to 0, So, but try to understand, generally students they thought of that in the denominator approaches to 0, but it is never equal to 0. Therefore, the numerator is also approaches to 0, but it is never equal to 0. Understand? Try to understand this. Okay. Both are approaching to 0, but they are not taking the value 0. So, that is the same concept I used here. Afterwards, I solved this problem as usual using L hospital rule. I got another equation. I solved these two equations. I got a value and b value. I substituted. I get the answer. Okay, now. I hope that you understand this concept very well. So, let us see some more problems. Welcome to a very small problem. So, this is a limit extends to 0, 1 minus x whole power 1 by 5 minus 1 by x. What is the value of this? Okay, now, right. So, let us try to find out this value, right. So, you can do if as x tends to 0, if you observe 0 here, if you substitute 0, you will get a 0 by 0 form. You can do L hospital rule, that is one of the method. L hospital rule is another method. What is the another method except L hospital rule? How can you solve this problem? Yes, of course, L hospital rule is very easy one. I can solve this. So, limit extends to 0. So, differentiation is 1 by 5. 1 minus x whole to the power of 1 by 5 minus 1 minus 4 by 5 upon x value is 1. As x tends to 0, so x value substitute here 1 to the power of minus 4 by 5. So, that is a fourth root of 1 to the power of minus 5. So, it will be minus 1 by 5. This will be the using L hospital rule, you can solve it easily. But here we are getting a little bit doubt. What is the doubt? So, as x tends to 0, you are getting 0. 1 to the power of minus 4 by 5 value is how much? That we are getting a little bit doubt. Okay. So, this is a minus 1 by 5. So, without getting that doubt, how to solve this problem? How to solve means a very easy problem is that is equal to limit x tends to 0, apply the binomial theorem. So, that is x a minus x, that means a minus b whole to the power of 1 minus x whole to the power of p by q. What will be the first term? 1 minus, so this is equal to p into x by q plus so on, it will come x square minus p into p plus q by 2, p by p 1 factorial. Next term is p into p plus q by 2 factorial into x by q whole square. Let it go, it goes on. So, no need of taking that many times. Why? Because the denominator, the degree is 1 only. Therefore, up to here 2 terms are enough. So, this is equal to 1 minus p means 1 times x by 5. No need of remaining terms. That means why? Because denominator x is there now. Anyhow, x square x will get cancelled. Okay. So, the last term is minus 1. This is minus 1 separate. So this plus 1 minus 1 will get cancelled. X is also cancelled. Minus 1 by 5 is your answer. Understand, dear students? So if you approach, this is a if you approach using this L-Hospital rule, here you will get a little bit confusion. Why? Because if you extends to 0, if you put 0, 1 to the power of minus 4 over 5, generally you think of that 1 raised power, any value that is equal to 1, therefore you will get the answer 1 by 5. If you approach the L-Hospital rule sometimes. But the answer is minus 1 by 5. So if you go for binomial theorem expansion, so this is the first term is 1 minus, write the second term itself, enough, that is minus p by 1 factorial into x by q, that is minus 1 by 1 factorial into x by 5. No need of remaining x square terms. Why? Because even though if you write down x square terms, x square by x, x will get cancelled, you will get x 0, limit extends to 0, 0, all remaining all terms they tends to 0. So here plus 1 minus 1 will cancel, x will cancel, your answer is minus 1 by 5. So be careful about while applying the L-Hospital rule. Okay, na? Right. So I hope that you understand this concept. So let us go for next problem. Limit extends to 1, x plus x square plus x cube plus so on x power n minus n upon x minus 1. Okay, now how to solve this problem? Okay, right. If you observe, if you substitute x tends to 1, here 1 plus 1 square plus 1 cube plus so on 1 power n is there. So sum of the n terms is n. Sum of 1 plus n terms means n minus n 0, 0 upon 0. You can go for L-Hospital rule. So if you observe L-Hospital rule, then you can get the answer. But before that, generally I will do one method. Let us see generally students where the mistake is committed. Okay, yes, let us see that. So limit x tends to 1. So see here, x plus x square plus x cube plus so on x power n is it is an arithmetic progression with first term x common ratio x. That means what is the formula? A into r to the power of n minus 1 by r minus 1. Okay, na? So this is equal to x into x to the power of n minus 1 by x minus 1 minus n by x minus 1. Understand this? A into r to the power of n minus 1 by r minus 1. Same here, minus n is there, here denominator x minus 1 is there. So we have in limits, we have very important formula, that is limit x tends to a, x power n minus a power n by x minus a is equal to n into a to the power of n minus 1. N into a to the power of n minus 1. So if you observe here, apply the limit here, limit x tends to 1, x power n minus 1 upon x minus 1 is equal to how much? Yes, we can write down x 1 power n here. So if you apply that formula, what you will get there? What you will get that n into, that is n into 1 to the power of n minus 1, that is equal to, you are getting n. So up to here you are getting n. Limit x tends to 1, x into, this value is equal to how much? N minus n by x minus 1. Okay, now? Right. So next one, limit x tends to 1, take n common outside, x minus 1 upon x minus 1. X minus 1 get cancelled, you are getting answer n. Is there any mistake in this here? Generally one student did this problem like this. Is there any mistake here? Yes, he first x plus x square plus x cube plus so on x power n. They are in geometry progression with the first term x and common ratio x. The sum to n terms of this progression Sn is equal to a into r power n minus 1 by r minus 1. So just like that is in the form of our standard form, limit x tends to a, x power n minus a power n by x minus a, n into a to the power of n minus 1. He applied here, so he got n, here xn minus n by x minus 1. take n common outside, x minus 1, x minus get cancel n. What is the, is it the correct answer? Is it the correct answer? Is it the correct answer? No. It is a wrong solution. It is not a correct procedure. The answer is wrong. Why the wrong answer means, always remember, applying limit both numerator or denominator or any product or sum or anything, that should be your final step. That should be your final step. Here your applied limit extends to 1 up to here one part of the problem. One part of the problem, that is wrong. That is wrong. You should not apply the limit extends to whatever may be that to one part of the problem. You should not apply. You should apply limit extends to 1 to the whole function. Whatever may be the function, you have to apply the whole function. That will be the, after that step, no limit should come. So, no limit, once you limit extends to 1 or extends to 5, extends to 6, you are applied, this should not come. It should not come. That way final. Afterwards, we will simplify that, we will get the answer. Here, what the mistake done is, he applied limit extends to one part of the function. One part of the function, again limit got. Again we got this step, limit extends to. That is wrong. That is wrong. So, always remember, you should not apply the limit as far as you like. Okay. You should not apply the limit to one part of that function and we will get the answer from out of that. Again limit applying. No, not like that. So, limit, if you are applying to a function, that next step function limit should not be there. Next function, that will be the final step. After complete simplification of the function, if it is not in the 0 by 0 or infinity by infinity, then only you have to apply the limit. Okay, na? So, I hope that you understand this concept, but what is the actual procedure of this problem? Okay, how to solve this problem? Now, I am going to tell. So, here n is the wrong answer, but what is the correct answer? Welcome back to this problem. So, I am going to see the actual mathematical procedure. Okay, right. Then how to do this problem? So, very easy. So, I am going to do this problem. Limit extends to 1, x plus x square plus x cube plus so on, x power n minus 1. 1 is there, no? 1 means what? Can I write down sum of 1 ones so on 1 n times whole divided by x minus 1. Okay. Now, what I am going to do this now? This 1 plus how many ones are there? N ones are there. That is why each one distribute for x square, x cube, each one you separate. That means limit extends to 1, x minus 1 plus x square minus 1 plus x cube minus 1 plus so on x power n minus 1 whole divided by x minus 1. Is there any wrong in this step? Nothing wrong is there. Why? Because n means 1 plus 1 plus 1 and ones are there. So, each one you distribute this part. Here also how many terms are there? 1, 2, 3 so on n are there. 1 you distribute for 1 for x, 1 for x square, 1 for x cube, right. After distribute this 1 to each x square, x cube so on x power n. Now, let us distribute here x minus 1 by x minus 1. How much you are getting? 1 plus. See here we have formula. Limit extends to 1. X power n minus 1 power n by x minus 1 is equal to n into 1 to the power of n minus 1 is equal to n. Okay, now. So, n into a to the power of n minus 1 means n. So, here also x square minus whole square means what? 2 into 1 to the power of 2 minus 1, that you are getting 2. Here also, here you can write down 3. 3 into 1 to the power of 3 minus 1, that is 3 into 1, 3 plus so on, last term is n. X power n minus 1 power n by x minus 1, last term is n. So, this is nothing but sum of the first n natural numbers, nothing but n into n plus 1 by 2. This is your final answer. So, in the whole problem, whole problem. See here, limit extends to 1. I applied for each and every function. Am I getting here any limit here? Again, I am getting limit? No. Am I getting any limit? No. Limit extends to a or a limit extends to 5. I am getting no. This will be the final answer. Like that you should be there. So from this concept, what you have understood? So you should not apply the limit as you like in between any functions should not. So applying the limit should be the final concept, final step. This is the answer. So here up to here I simplified this function. Okay, I applied the limit extends to for each and every function. Ultimately I got the answer. So for this problem, n is not the correct answer. N into n plus 1 upon 2 is the correct answer. I hope that you understand this concept. Okay, na? So let us see some more concepts. One more problem, very interesting problem. Evaluate limit extends to 0, step of sin x by x and step of limit extends to 0 sin x by x. So this is a greatest integer function. So it is not just like ordinary bracket, it is a greatest integer function. Both are not same. Try to understand. Here it is a greatest integer function is for sin x by x, but it is total limit extends to 0 sin x by x. Then what is the value? Both are same. Same answer you are getting? No, not at all. Now try to understand this problem. So try to understand this problem. First I will see what is sin x by x. What is sin x by x? Try to understand. This is what happens. Observe the, if you understand this problem, if you go for graphical approach, the problem will be very, very easy. So let us try to draw the graph of y is equal to sin x, y is equal to x graphs. Y is equal to sin x and y is equal to x graph. Let us observe those graph, what happens you see. So this is equal to x axis and it is y axis. This is 0, this is some pi by 2. So this is minus pi by 2, enough. Why? Because as x value approaches to 0, right? We know that sin 0 is 0. So here it is 1. So it will come sin pi by 2. Again it will come like this. That is up to here minus 1. So here it is minus 1. That is the graph of y is equal to sin x. Now y is equal to cos x. So this is, sorry, y is equal to x. This is y is equal to x. Okay, na? Y is equal to x. That is a straight line passing through origin making 45 degrees with x axis. If you observe, as x value approaches to 0, as your x value approaches to 0, your sin x graph is less than x. See here, sin x is less than x. Am I right or wrong? In both the ways, as x approaches to from right hand side and approaches from left hand side. So here sin x, as x value approaches to in the both the direction, either plus or minus, sin x graph is less than x. Always sin x value is less than x. See the graph, sin x is less than x. Here also sin x is less than x as x value approaches to 0. Okay, now that means what? Sin x by x value less than 1. X we can divide both sides. We can divide with x on both sides, no problem. Why? Because as x value approaches to 0, but x is not equal to 0. Okay, so therefore x is not equal to 0 means you can divide with x on both sides, no problem. Observe here, sin x is less than 1 means what? This value is approximately 0.99999 like this. Less than 1, it is not exactly 1, 0.99. So what is the value of sin x by x value is step of 0.9999. So that is you are getting 0. You are getting 0. Understand this concept? Okay. Therefore, limit x tends to 0. Step of sin x by x value is 0. That is 0. Okay, now what about that case? That case anybody can tell. What is that case? So limit x tends to 0. Sin x upon x step. That is sin x. In the whatever may be the present in this function, this value we know. Limit x tends to 0, sin x by x value is 1. Already we know theorem where x is measured in radians. Okay. So step of 1 is equal to 1. So the first function value is for, as you approach for both from left hand side and right hand side, sin x value is less than x. Therefore so since x is not equal to 0, you can divide on both sides. So therefore sin x by x less than 1. That means as x tends to 0, sin x by x value tends to 1. It approaches to 1. Therefore 0.9999 is less than 1 means what? It's going, the total function sin x by x is always less than 1 means its value approximately 0.999 you can take. Therefore the greatest integer function is equal to 0. Understand this? So dear students, so for this value is 0 and this answer is 1. Both are not same. Okay now? Right. So I hope that you enjoyed today's class, and tomorrow's class with tomorrow class I am going to come with a very important property, that is continuity of a function. Don't miss that video. Then how to say that a given curve is continuous. Continuous. What is meant by continuous? What is meant by discontinuous? How can you check the continuity of the function using the concept limits? Okay. I hope that you enjoyed today's class. In the tomorrow's class with some more problems and some more concepts, I will stand before you. Until then, all the best.